Hello, Adam here. So today I will show you what is the latest revision of my GPS locator project. So I worked hard for something like 2 weeks to optimize the behavior of this device to reduce the current consumption, and finally I ended up with a device that can work something like more than 1 month on the single set of 3 AA batteries. So we have something here connected. So these are the cheapest 3 AA batteries that we'll be using, and on such set of batteries it can work 1 month. So I think that's a good result, and you can achieve even more if you work on the code. So probably it would go down to sleep for more than I did. And what have changed in the solution? So I have connected the signal ring from the SIM800 module. So the ring is a signal from the board that we inform by changing states to the ground when there's an incoming call or incoming SMS, and this signal will wake up the ATTINY 2313 MCU by the interrupt 0 pin. So the MCU will by most of the time be sleeping, and will be waking up this one by using a ring pin from the SIM800. So SIM800 will also go down to the sleep, but while sleeping it will receive information from the network. It will get the calls and will get the SMSs, and that will be very useful to wake up the MCU, because when this ATTINY is sleeping, the power consumption, the current consumption is something like, I don't know, less than 400 of nanoamperes. So in the theory this device will work at least 1 month on the single set of batteries, so we'll see. So I have connected the amperometer here, so to show you what's the behavior of this device when it's powered up, when it logs to the network, and when it's receiving calls. Okay, so maybe I will switch this one on. Okay, so when it's booting, the amperage is much more than 100 of milliamperes, and when it registered to the network, then the current drops down to something like 20 milliamps, maybe more than this. Oh, you saw the spike. So the spike was when it was sending something to the network. It may even draw the current up to 2 amps, so you have to be prepared. You have to have enough tick of the connections. Okay, so as you can see, when it's powered up and when it goes down to the sleep mode, also the MCU goes down to the sleep mode, to the power down actually. So the power consumption gets reduced to 1.6, 1.5, something like this, and that in theory will give you on the single set of the cheapest AA battery, which are rated something like 2000 of milliamperes hour. That would give you something like 1 month probably. So I will test it. I'm going to test this. And of course, if you use some kind of I don't know, accus here, probably get something like 2 months of work, or maybe more than this. So that would be sufficient to hide this device within the car or within somewhere in a bike, just to track your bike or car if it's stolen or not. Okay, so someone may ask me, why haven't you used something like ATMEGA 326P or something like this? So the ATMEGA is such big. So if you compare it with the size of this, it will almost take half of the board. Maybe if you have a surface mount version, that would be, and you can solder this one, That would be very useful, but I can't, so I just simply use the ATTINY. And of course you can make some improvements to this, so it is a first revision. It is my first project on ATTINY, so on ATTINY 2313, so maybe it's not perfect, but it works. Okay, let's see what happens when I call this device, when it will try to send SMS. What's the amperage then? I will now try to call this one by my phone, and in return it should send me an SMS message with the location, a text message with the location. Okay, I'm calling it. You can see that the amperage is higher, gets more than 120. Now it will try to contact Google to pull the GPS data and send an SMS. The amperage will go high. Oh, there's a spike even more than 200 of milliamperes. So in the theory, in the spec, it is written that the SIM8xx would even use something like 2 amps. So you have to be prepared, and you have to have good cables, so that such that would enable you to draw such kind of amperes. If you can see my circuit board, so it's I used a lot of solder to enable this one to handle such kind of current like 2 amps. So I think it is enough, and I will see if it's working well on the field. So I also have some small housing to this. So let's see how it fits. I should have disconnected this cable, so otherwise it didn't fit. And I also attached some kind of small heatsink to this TO220 based LM7805, just in case I would be using this one to prevent from heating up this, to prevent from switching on some kind of, I would say, safe mechanisms. Also, you have to remember that when using this one, make sure that you have some fuse inside, okay, just not to break your car battery. Okay, thank you very much. I think that's all for today, and I give you some feedback after 1 month after testing of this device. Bye bye.